So today is all about comparing numbers to questions, and whether that's multiple choice possibilities or, more importantly, let's say you do a bunch of math work and you get an answer. It's that last step of every math problem that no one does, and it's looking at that answer and seeing if it makes sense. A lot of times you guys are so excited to get an answer, you write it down and you move on. It feels good. I solved the problem. Hey, I came up with a number. It's not even an ugly decimal. It's not a negative. It's just a beautiful number 12. I'm going to write that down. And the part where you're supposed to think about that answer in the context of the problem completely gets overlooked, right? So we're going to talk about a few of these things today. This is going to be a little bit harder of a video because I'm going to be bouncing around a lot. Today would be a really good day for you to have been in class. So hopefully no one is watching this video because you all were there today and you were all a part of the discussion, and you kind of got to bounce around the thoughts with us instead of trying to follow it after the fact. But I'm just going to touch on a few of the basics today. A lot of this is stuff you've heard. I'm not going to go over all of these problems, but we're going to go through some of them maybe quickly, maybe a little bit more time. So number 3, here's an ACT question about a copy machine, 2 copy machines making paper. At one point, you probably had a teacher that told you it's not, usually you can just cross off the biggest and the smallest answers. You can just go through and you can get rid of the biggest and the smallest. You got to be really careful with the ACT and multiple choice questions because A, they know that, and B, like this number 1, actually the biggest one ends up being the correct answer. But that doesn't mean you can't use the size of the number to help you eliminate things. If you're making 60 copies for 8 minutes, you're already at 480, and you haven't even considered the second copy machine. So it's not going to be just 480 because you've already just done 1 copy machine and reached 480. That's an easy one to eliminate, the small one, but you can't just automatically eliminate the big one because, again, it ends up being the correct answer on that one. Number 4, Marlon is bowling in a tournament. He has the highest average after 5 games. And then it gives you his average scores, his scores, 210, 225, 254, 231, 280. So his biggest score is 280. His smallest is 210. He's going to play 1 more game, and he wants to keep his average the same. Well, we don't know what the average is, but I can eliminate some things pretty quick. His smallest score was 210. So his average is going to be higher than that. It's going to be somewhere between 210 and 280. So I know that 200 is not going to help me keep the same average. 210 isn't even going to help me keep the same average because that's just my lowest number. The number is going to be between 210 and 280. So already I can quickly eliminate 2 of them. The other 3, 231 happens to match a number in the problem. It's trying to confuse you with the median and the mean and what those are. So 231 is not likely, but I don't know if I can automatically eliminate it because it's still in between 210 and 280. Okay. Number 5, Joelle earns $7.50 an hour and she works 40 hours a week. How much does she earn in 42 hours if she gets paid extra for working over 40 hours? If she's working 40 hours and making $7 an hour, we're just going to do quick math. We're not even going to use $7.50. $7 an hour, 4 times 7 is 28, add a 0. She's making more than $280. So that one's already gone. This one, you could probably eliminate the big one too. She's only working 2 extra hours. She's only working 42 hours instead of 40 hours. So the 472 is probably way too big. The 378 is probably way too big. The other 2 are reasonable answers. So now you're only having to figure out between 2 instead of 5 answers. The discount question. I love this, number 8. Discount tickets to a basketball tournament sell for $4 each. I'm over here now. Enrico spent $60 on tickets. So he spent $60. That's $37.50 less than if he had bought them at a regular price. So he saved, I don't know, about $40. I'm not worried about the decimals right now. I'm just thinking through the problem. What was the regular amount of a ticket? So when I look at, he spent $4 per ticket, and he spent a total of $60, and he saved $40. So he saved less than he spent. That means the amount that he saved is less than the ticket price. In fact, it's what? A little bit more than half? It's not half of what he spent, but it's a little bit more than half. So a little more than half. Well, $2.50 is less than $4. $11 is way more than $4. $7.50 is a lot more than half more than $4. So again, you eliminate 3 really quick. I love that they put $2.50 in here because it's like, why would they put the ACT when it writes questions and it gives wrong answer options? Those are numbers that you could come up with somehow. So when you see $2.50, why the heck would they pick a number smaller than the $4 for the regular price? And then you start to analyze and you think, oh, maybe that's the discounted amount. So maybe if I add that to $4, I get the regular ticket price, which is $6.50, which happens to be the right answer, I think. I would assume, because I don't know why else they would put $2.50 in there. So right there, I would have guessed, $6.50, because if I take the $2.50, add it to the 4, that $2.50 had to come from somewhere. It's not just a random number, right? Let's see. Sometimes you don't know you can't eliminate things right off the bat, but as you start doing the problem, you can start to eliminate things. A rectangle has an area of 32 square feet. So if I have a rectangle, and the area means I take one side and multiply it by the other side, right? What's the shortest side of the rectangle? And it gives me a bunch of options. Well, we can start plugging them in. If 1 was the shortest side, it's got to multiply to be 32. So 1 times 32, that makes the square feet, but the perimeter is only 24 feet. I already have a side that's 32 feet long. That's not going to work. If this is 2, this has to be 16. Those are already going to add up to be more than 24 when this is also 16. So 2 is not going to work. Well, let's jump to the big one, 8. If this is 8, well, 8 times 4 is 32. That works. But this is supposed to be the short side. But 4 is shorter, so that one's not going to work. So I can get rid of the top one too. So quickly, as you start doing the problem, you may not be able to eliminate things right off the bat, but as you're solving the problem, you can start to eliminate things. Number 12, we're going to skip because that one right off, you can eliminate lots of those. See if there's some better examples here. The basketball drill. I like this question. 5 basketball players are standing in a circle. So 1, 2, 3, 4, 5. Those are my basketball players. They're going to pass the ball around. They can't pass it to the person next to him. So if this guy starts, he cannot give the ball to this person or the last one that passed it to him. Okay. So if it came from this guy, he couldn't pass it to anyone but this one. All right. A designated player begins the drill as the first passer. This player will be the receiver when? So when is this guy going to get the ball? We can start trying to eliminate things. If he was the 4th one, that meant that the ball would go to 3 of the other players and then back to him, which means it would just keep going in this pattern. It would never hit that 5th person. So that's very unlikely. It's going to be 4. If it was 24, that means after he passes it, it bounces to everybody but him. and then eventually it happens to go back, that doesn't make a lot of sense either. Same with the 10th. That means after he passes it, everybody else is going to get it twice before it comes back to him. Again, that's not going to make a lot of sense. So now you're down to 5 or 6. You can work your way through the problem, see if it makes sense. Number 35, Jerome, Kevin, and Seth are eating sandwiches. Jerome ate half, Kevin ate a third, Seth ate the rest. What's the ratio of how much they ate? So here's Jerome, here's Kevin, here's Seth. Well, Jerome ate the most, so his number should be bigger than the other numbers. So that got rid of 2. Kevin ate more than Seth, so Kevin's number should be bigger than Seth's number. So now you're down to 2 choices. Now you can start doing some math and figure out which one of those is the correct one and see if it makes sense. Do we want to do a couple more? No, let's talk about another situation, right? It's easy to sometimes eliminate things, but what about if you don't have multiple choice and all you're doing is looking at your answer and trying to decide, does your answer make sense in the context of the problem? Okay, so here I've got a formula, the interest formula. So this formula tells you if you put money in the bank and you earn interest on that money, how much interest are you going to earn? That's kind of what this formula is going to tell us. So interest, if you don't know, you put money in the bank uses your money to go make money. It invests it, it does things with it, it earns money with your money. It doesn't just sit in a vault. Because they're using your money to earn themselves money, to make it fair, they give you a percentage of money that they earn. And that's called your interest rate. The amount that you get is called your interest. So if I put $1,000 in the bank, that's called my principal. That's right here. That's P. And I earn 3%. That means they give me 3% of my money I earn back as interest. And I want to know how much interest I'm going to earn in 2 years. So if I plug these numbers in, I equals 1,000 times 3 times 2, and I end up with 1,000 times 3 is 3,000. 3,000 times 2 is 6,000. Wait a minute. I put $1,000 in the bank, and I earned $6,000 in interest. That's way more than the money I even put in the bank, and I'm only supposed to be earning 3%. I must have done something wrong. That doesn't make any sense. If that made sense, everyone would be a millionaire because you could put money in the bank and you're making more money than you put in very quickly. That would be awesome. I wish banks worked that way. It doesn't happen like that very often. Sometimes people make a really good investment into a stock and things make a quick change. But in the real world, in the daily life, no, that you don't earn $6,000 in interest by giving the bank $1,000 of your money to hold on to, right? So that tells me I might have done something wrong. I should go back and look at what I did. What we did wrong is the 3 is supposed to be 3%, not the number 3. So this should have been 0.03, not 3 alone, not just a regular 3. And then what you would have ended up with is $60 instead of $6,000, which makes a lot more sense in the context of the problem. Perimeter and area. This one happens all the time. You guys mix up, is the perimeter when I add things together or multiply things together? Well, remember the perimeter is the distance around the outside. So if I have this wall or this fence, we'll call it a fence around something, I don't know. And it's 20 feet wide and 10 feet long, which means this is also 20 feet and this is also 10. What's the perimeter? What's the distance around the outside? Oh, I don't remember if I'm supposed to add the numbers together or multiply. Well, if I multiply 20 times 10, that's 200. I'm already at 200 and I haven't even looked at these two numbers yet. If I wanted to walk around this fence, would it make sense that I'm going 200? No, this is only 20, this is only 10, this is only 20, this is only 10. So 200 doesn't make sense. That seems way too big to be the distance around the shape. If all I do is multiply right down 200 and I don't think about that number in the problem, I'm not going to catch that I did something wrong, okay? So we're going to do a lot more examples in class. Try to get the notes from a friend if you weren't here. And then I gave you a worksheet. It looks like this, and it gives you a bunch of questions. Most of these, I went ahead and I gave you answers. I didn't want you doing work without multiple choice answers to lean on. But what you're doing is you're looking at these questions, and whether you do it right off the bat, if you start crossing things off, this doesn't make sense, this doesn't make sense. I want you to tell me what answers don't make sense, and I want you to tell me why. You don't have to do that right at the beginning. You can start solving the problem first. You can come up with the correct answer first, and then decide why these other answers might not make sense based on what you found. All right? So you are writing, you are explaining. It says to use complete sentences. We haven't done that in this class yet. It is something you're going to need to get used to in math class. So tell me why an answer does not make sense, or tell me why an answer would make sense. It can go both ways. Okay, this number doesn't make sense because X, Y, and Z. But you can also tell me why a number makes sense to be one of the answers to the problem.